Forget vampires. The real secret to eternal youth lies with the masters of the night. Bats. Imagine a tiny creature, smaller than your hand, living 40 times longer than you should. That's not fiction, friends. That's bat reality. But how do these furry flyers cheat death while mice and hamsters shuffle off after just a few years? Buckle up, because you are about to dive into a world of superhero DNA, hibernation hacks, and an immune system that laughs at Ebola. We'll crack open the science behind bat longevity, revealing secrets that could unlock the key to slowing down your own aging clock. Think wrinkle-free wings and youthful squeaks. The future is looking batty and awesome. So, ditch the anti-aging creams and join me on this scientific adventure. The average lifespan of a mammal, when scaled to body size, is a mere fraction of what bats boast. A small rodent, for instance, may eke out 2 to 3 years, while a comparably sized bat can live for 20 to 30 years. Even larger mammals, such as domestic dogs or wild deer, often clock out at a decade or two. Yet, bats, in their quiet, nocturnal existence, defy these norms. Some, like the little brown bat, can live well into their 30s, a feat that leaves other similar-sized mammals in the dust. But the real marvel, the pièce de résistance, is the Brandt's bat. This tiny winged mammal, no larger than a human thumb, can live up to an astonishing 41 years. To put this into perspective, that's akin to a human living for over 200 years. It's a feat that outpaces even the longest-lived humans, such as Jean Calment, who reached the ripe old age of 122. This longevity isn't an isolated case or an anomaly. It's a pattern, a standard, a rule, rather than an exception in the world of bats. They are the Methuselahs of mammals, the grand old bats of the animal kingdom, outliving peers and predators alike. A question that we'll delve into, scrutinize, and explore in the coming scenes. Let's embark on this journey of discovery together as we unravel the secrets of these long-lived, enigmatic creatures.
One key to bats' longevity lies in their slower metabolic rates. Unraveling the enigma of bats' extended lifespan, numerous studies have found a fascinating correlation between metabolic rate and lifespan. Metabolic rate, in essence, refers to the amount of energy an organism uses per unit of time. It's akin to the ticking of a biological clock, and the pace at which it ticks can have profound implications on an organism's lifespan. In the vast tapestry of life, there exists a general trend. Creatures with faster metabolic rates typically have shorter lifespans, while those with slower metabolic rates live longer. This pattern is often referred to as the rate of living theory. However, like any rule, there are exceptions, and bats are one such intriguing exception. Despite being small mammals, bats have a metabolic rate significantly lower than comparable species. Consider this. A shrew, a small mammal roughly the size of a bat, has a metabolic rate that's nearly 3 times higher. This rapid metabolic rate results in a high-energy lifestyle, which unfortunately often equates to a brief lifespan. Bats, on the other hand, defy this trend. They have mastered the art of balancing high-energy activities like flight with a slower metabolic rate, contributing to their extended lifespan. But how do bats achieve this metabolic marvel? One theory points to their ability to adjust their metabolic rate based on activity levels. When bats are in flight, their metabolic rate spikes, but when they're at rest or in hibernation, their metabolic rate drops significantly, conserving energy and reducing wear and tear on their bodies. Furthermore, bats have an efficient system for dealing with metabolic waste products, which can cause cellular damage if not properly managed. This efficient waste management, combined with a slower metabolic rate, decreases the rate of accumulated damage, thereby extending the lifespan of these fascinating creatures. This slower metabolic rate, along with other factors we'll explore later, contributes significantly to the longevity of bats. It's a captivating testament to the complexity of life and evolution, demonstrating that there's more than one way to live a long life. A slow and steady metabolic rate, it seems, indeed wins the longevity race. Beyond metabolism, bats possess superior mechanisms for DNA repair. Deep within their cells, the machinery of life tirelessly operates to mend broken strands of DNA, the very blueprint of existence. Aging, at its core, is a cascade of cellular damage spiraling into the deterioration of function and form. Yet, bats, in their quiet defiance, have developed enhanced mechanisms to stave off this relentless onslaught. These nocturnal creatures boast an extraordinary activity in genes associated with DNA repair, far outstripping their mammalian counterparts. Picture a production line of diligent workers ceaselessly repairing and rectifying, allowing the bat to maintain its biological integrity. This is a war against time, waged at the microscopic level, with bats holding the line against the inevitable march of aging. The genes associated with DNA repair are like vigilant sentinels, tirelessly working to keep the bat's cells in optimal condition. This genetic fortitude affords bats a remarkable resilience, a cellular elixir of life, if you will. In the realm of DNA repair, bats truly are the superheroes of the mammal kingdom. Bats' longevity secret also involves their unique immune system adaptations. You see, the immune system of a bat is a marvel in itself, distinct from those of other mammals. It's like the unsung hero working tirelessly in the background, fighting off threats and ensuring the bat's survival. One key aspect of this is their ability to suppress inflammation. In many mammals, including humans, inflammation is a double-edged sword. While it's a crucial part of the immune response, chronic inflammation can lead to a host of health issues, from heart disease to cancer. But bats, they've got this figured out. Their immune systems have evolved to strike a delicate balance, providing robust defense against pathogens without triggering harmful inflammation. This is achieved through a unique selection of immune genes and pathways, including a dampened NLRP3 inflammasome. This molecular complex, present in many animals, is typically responsible for triggering inflammation in response to infection. But in bats, it appears to be less responsive, reducing the risk of chronic inflammation and contributing to their long lifespan. But that's not all. Bats are also known for their resistance to diseases, including those that are fatal to other species. Their immune systems show an extraordinary ability to control viral replication, and this is thought to be linked to their long lives. You see, bats are natural reservoirs for a wide variety of viruses, including some that cause severe diseases in humans like Ebola and SARS. Yet bats remain unaffected, and this is largely due to their unique immune responses. Bats have what's known as a heightened interferon response, a part of the immune system that inhibits viral replication. In bats, this response is always on, allowing them to control viral infections without succumbing to disease. It's this remarkable combination of inflammation suppression and disease resistance that sets bats apart. These adaptations provide them with the tools to combat threats that would otherwise shorten their lifespan. In the face of disease and inflammation, bats stand resilient, aiding their lengthy existence. Lastly, bats' lifestyle choices and hibernation habits play a crucial role in their longevity. The nocturnal and dietary habits of bats form an integral part of their longevity puzzle. Being creatures of the night, bats have adapted to a life that is intrinsically different from most mammals. This nocturnal existence allows them to evade many daytime predators, reducing the risk of premature death. Their diet, primarily consisting of insects and fruits, is high in antioxidants, which are known to counteract harmful free radicals in the body, thereby reducing cellular damage and promoting longevity. The consumption of insects also provides bats with a rich source of proteins and essential nutrients, further enhancing their vitality and lifespan. But it's perhaps their hibernation habits that provide the most significant contribution to their long lives. Hibernation is a state of inactivity, characterized by low body temperature, slow breathing and heart rate, and low metabolic rate. During hibernation, bats enter a state of torpor, a short-term hibernation, allowing them to conserve energy, reduce metabolic waste, and essentially slow down the aging process. In this state of torpor, the bat's metabolic rate drops to just 2% of the normal rate. This dramatic decrease in metabolic activity helps to reduce cellular damage and the accumulation of harmful byproducts that contribute to aging. Essentially, during hibernation, bats are able to press pause on the biological clock. Interestingly, the duration of torpor varies from species to species, with some bats hibernating for a few hours, while others enter this state for months at a time. Regardless of the duration, this period of inactivity allows bats to conserve resources, survive harsh environmental conditions, and extend their lifespan. Through a combination of lifestyle adaptations and hibernation, bats have found a way to slow down time. This unique blend of nocturnal habits, a diet rich in antioxidants, and the ability to enter a state of torpor has equipped bats with a toolkit for longevity, setting them apart in the animal kingdom. So, what makes bats the Methuselahs of the mammal world? One might say it's a symphony of survival strategies. Firstly, their reduced metabolic rate is a crucial player, acting as a brake on the relentless wear and tear of life. This metabolic moderation allows bats to slow the ticking of their biological clocks, extending their lifespan far beyond that of similar-sized mammals. Secondly, their DNA repair mechanisms are akin to a master artisan, meticulously mending the inevitable damage that comes with time. This enhances their genomic stability, reducing the risk of age-related diseases. Thirdly, bats have immune system adaptations that are nothing short of evolutionary marvels. Their immune systems, unlike ours, do not wage war on their bodies as they age. In addition, lifestyle factors such as their nocturnal habits and communal roosting offer protection from predators and environmental stressors. Finally, hibernation serves as a protective mechanism, offering a seasonal pause button on aging. In the quest for longevity, there is much we can learn from these fascinating creatures of the night.